Good day, everyone. Today, we want to look at logarithm involving simultaneous equations. Here, we are to solve for x and y. In logarithm to the extent of x plus logarithm to the extent of y equals to 4, and logarithm to the extent of x plus 2 log to the extent of y equals to 3. Today, we are going to use this particular method. And the method is that we are going to represent log to the extent of x with a letter. And we also represent log to the extent of y with another letter. So let's say logarithm to the extent of x to be p. We are representing it with p. The second one, log to the extent of y equals q. So what we'll do now, we'll replace p with log to the extent of x, replace q with log to the extent of y. Now let's do that. This will be p plus q equals to 4. That is equation 1. The second equation, this is still log to the extent of x. That will also be p plus 2q. That will be plus 2p equals to 3. We can solve these two equations simultaneously using elimination method. We can also use substitution method, but today we want to use elimination method. Elimination means we need to remove one of the variables. We have two variables here, variable p and variable q. Now, when you want to use elimination method, you have to check for any of the two variables that is convenient for you to eliminate. Now, when you want to use elimination method, there are rules guiding it. Number one is that the variable you want to eliminate must have same coefficients. Now, let's look at the board. We have P and Q. When we check P, the coefficient of P here is 1. The coefficient of the second P also is 1. So their coefficients are the same. That is rule 1. Rule 2, you also check for the signs. So which means I've decided to eliminate P. So rule 2, I have to check for the signs. The sign here is invisible plus. The sign here is invisible plus. This to tell us that this is a positive P, this is also a positive P. So the signs are the same. When signs are the same, we are going to subtract. It is when the signs are different, you subtract, you add. But here the signs are the same, we are going to subtract. So we'll subtract this, we also subtract this, and we'll subtract this. What would that give us? We have p minus p. P minus p will give us 0. So which means I've been able to eliminate p. P is 1. Now in the second one, this one, for q, we are having two signs here. That is minus times plus. Let's see. Minus times plus 2q. Minus times plus will give us minus. That will be minus 2q. Then that means here is minus 2q. Then the up one. The up one we have plus q. Before we and right, plus q. Minus 2q plus q will give us minus q. Why did we say that it's minus q? Well, check. The one with negative is more than the positive. So which means what you are going to have will still be negative. Negative of 2, positive of 1. So we are having higher negative. So your sign will be negative. Then you now say 2 minus 1 because the coefficient here is 1. 2 minus 1 is 1. Then what's variable? Variable q. That should be minus 1q. But in mathematics, My 1 cube and cube are the same. So instead of writing minus 1 cube, we decide to write minus cube. So which means here is minus cube equals to, what do we have here? 4 minus 3, that is 1. The letter we are looking for, we are looking for cube. So the letter shouldn't carry the negative sign. So in this case, the coefficient of q here is minus 1. So we are going to divide both sides by minus 1. This is over minus 1 over minus 1. Then minus cancel this minus. We now have q over 1. Q over 1 is q equals to 1 divided by minus 1 will give us minus 1. Our q equals to minus 1. We've gotten q. We need to get the other variable. Which is q. We've gotten q. The other variable is p. We need to get p. To get p, we are going to use any of the equations here. This is equation 1, the first equation. This is equation 2, the second equation. So I can decide to use the other one. But to get our p, I want to use equation 1, the first equation, which is p plus q equals 4. P plus q. Don't forget, we've already gotten q. We got q to the minus 1. So instead of writing here, I'll write minus 1 equals to what? The completion of this equals to 4. This is equals to 4. Now we can open our brackets. We have p plus times minus. That is minus 1 equals to 4. The next step is to collect like terms. Collect like terms. This minus 1 crosses over. Crossing over equality sign. When it crosses equality sign, it's the sign change from this sign minus 1 will change to plus 1. In that case, we have p equals to 4 minus 1 crossing over, it becomes plus 1. From here, p equals to 5. We have gotten p, we've also gotten q. Then we need to recall, don't forget, recall that log to the extent of x equals to p. And we have gotten p to the 5. So we have log to the extent of x equals to p. But what do we get for p? P is 5. We write 5. From here, we'll make use of the relationship between logarithm and indices. The relationship between logarithm and indices is that the base in logarithm will also be the base in index form. So here we have 10 to be the base. Writing it in index form will be 10 raised to power. Raised to power will always be what we are equating it to. So that will be 10 raised to power 5 equals to x. So our x is what? Our x equals to 10 raised to power 5. I can decide to write this 10 raised to power 5. X equals to 10 raised to power 5. We have gotten x. Then y, go to where we have. You recall this. That is log to the extent of y equals to q. Log to the extent of y equals q. And what do we get for q? For q we got minus 1. Minus 1. Still using the relationship between logarithm and indices. Our y, I can decide to start with this y. Y equals to, this is the base, this is the power. And when you are changing it to index form, y equals to this base will also be the base in index form 7. Then this will be the power raised to power minus 1. to get x to the 10 raised to power 5, we got y to the 10 raised to power minus 1.